This is very interesting, not least because it's a Otis component. I'm just going to plug it in fact, but because it's made in Germany, which means that engineering should be very interesting inside. So this is a door operator. You've just heard a relay click inside. No blinky lights or anything like that. It's very anonymous. But it has the main supply going in, and it has a variable frequency supply out. It's got 5 connections here. It's got the 3 phases, protective earth and the screen. And then it's got another connector over here for the encoder with screen ground, 15 volts, and T1 and T2. That'll be the 2 sensor positions, so it can count the number of pulses and the direction it goes in. And to program this, because this is basically a computer with a variable frequency drive, you get a serial interface, and it's the standard. I'm just going to bring it in. It's the standard tool that Otis engineers use. Is this a standard tool? Is this what they still use these days? Have they moved on? I don't think it is. I think they still use this because there's a lot of equipment like this still in use. And it's pretty much universal. These units are so programmable because as the Otis has evolved their communication protocols, they've just made stuff backward compatible just so you can use the modules in many applications and also retrofit them to old equipment. So to change parameters in this, you have this serial terminal. You've got the 6-button input and you've got the display, and this is normally used for telling this to do learning things. Well, let me demonstrate. I'll just press 3. It's missing a menu, but that's okay. So let's go to monitor and then status, and it will show you its current status. It says working. It doesn't know where the doors are because it detects that they're not hitting any of the switches, the end-of-travel switches, but it's got a measurement for the door at this point in time of 1050 millimeters travel. Other things? Days alive. Let's go look for that. So let's go to the maintenance. Days alive. It's quite low. I get the feeling this is a reconditioned unit, not sure. And if I press down to go, it says total cycles 4,000, which is a nice round figure. It's also not a high number for elevator doors, so I'm not really sure the history of this unit. If you want to find out the software version, it is test and 2. Oh, that's Days Alive. That's the one I've already looked at, isn't it? It is indeed. Software, let me just work this out. This is where I get completely lost in menus. The software dates back to 2007. I don't know how old this unit is. Interesting. The other thing, there should be another menu. There it is. 3, engineer, 4. And this lets you set things, well, it lets you actually see the status. Maximum motor current 4,500 is that I guess that's the stall current that it's going to actually detect and sort of take evasive action around. It's very, very clever. Pass protect limit 3%, stop distance 60 millimeters, end position range 20 millimeter, GSM position 150 millimeter. Is that the slowing position? I'm not really sure. Lock distance 33 millimeter. Lock speed 5 hertz, open and close. So you can actually set the frequency of the motor, the rotation of the motor. Anyway, I digress. I could just basically look at random menus. What we really want to see is what's inside this, and this is where really I should unplug it because it does contain spicy mama voltages in here. So I shall go, and I'm going to leave it for a moment because this, I just know, because it's a variable frequency drive, it will contain big, fat, beefy capacitors that are just waiting to end my life. So I'm just going to pause momentarily. 1 moment, please. I think that's long enough, although I obviously won't be trusting discharge resistors as having done the full job. The connectors into this are WAGO or WAGO terminals. So for MD, who says, oh, I don't trust these because they don't have screw terminals. I've come across them in Hussman, and well, here's an Otis unit that's been using them for a long time. They have a good pedigree. Let's pop that over there out the way and get these other connectors out before I try and get the lid off. These are very close together, so I'm going to have to use long nose pliers to tweak these connectors out, as opposed to just ripping them out by the cable. These are also keyed You see these little pins on the top. You cut off X number of pins, then put little blocking pins and things into the receiving connector, and it means that you can't plug the connector in the wrong position. Well, I suppose you could if you tried hard enough. No. Yes, there must be a combination you can do that. So I actually, I used to work in elevators, but like way back in the electromechanical era with a company that also did elevators as part of its electrical engineering work, but not the electronic ones. And I did go into Otis's office in Argyle Street in Glasgow, and I inquired about the availability of work and could have ended up there. But the receptionist told me that I'd have to be clean shaven to be considered for work. And, well, no. And I sometimes wonder, was that actually their real policy, that they expected their customer-facing technical staff to be beardless, or was it just her opinion? I always wondered that. So I've got my Swedish little socket set to open this German controller. Such as Europe. What would have happened? I think I'd have got bored very quickly at Otis, because as the electronics, oh good shot, as the electronics crept in, the interest aspect of elevators just got less in a way. I mean, they're more versatile, but because they can do a lot more with the electronics. Well, this is a good example of that. This is a very clever unit. But in a way, I kind of like the old electromechanical stuff. It was more challenging. I like technical challenges. Although having said that, I mean, your average engineer, it says it's got 2 stickers in this. It's got the danger high voltage, it's got the do not open sticker. Well, that's a good example. Is this going to come off? Is this going to come off? It's exciting. I'll just put that over there. What do we have? What do we have? Let's zoom down on this. Let's brighten the image up, because let's face it, it's not very bright now, is it? Because that's all dark and circuit boardish. Pew, that's better. What do we have? We've got incoming filtering here. We've got a spark gap, metal oxide resistors. We've got the capacitors, common mode suppression, choke. We've got a couple of inrush limiting resistors here. What are they? And we've got a little relay. Oh, is that relay bypass? That relay is bypassing. These are inrush limiting resistors to take the spike off it, charge these capacitors, and protect the rectifier, which I can see is underneath apparently, because I can see the symbols there. Oh no, I'm just going to take a look. Oh, I'm going to have to take this apart further. What else do I see? Yeah, I'm going to have to take it apart further. There's the IGBT module under there. Yeah, we need to see that. There's the microprocessor. What else is in the vicinity of that? Loads of opto-isolators for the I/O. And more opto-isolators here. Everything is well protected. This is what I would expect. A, of German engineering, and B, of Otis, who are, quite frankly, to elevators, they're the equivalent of fluke to meters. They're just like the pinnacle of engineering when you get to the technical side. Don't like the corporate side much, but I like the technical side. Tell you what, I'm going to actually start taking more stuff apart. I'm going to be cautious here. I still don't trust these big fat capacitors. Oh, what's the voltage rating? I just want to see if they're proper death beam capacitors. Yes, they are 450 volts, so they are death beam capacitors. Just watch out, anti-5G people. They're going to kill your babies with death beams. Those who have seen that Arseholes video will know who I'm talking about. Just because it's got a 400 volt capacitor, well, 450 volt, that's worse in this case. Is this going to fit through? Look at that. They've made a hole in the circuit board, just the right size for a standard socket. Isn't that just very German? Vorsprung durch Technik, as they say, or whatever it is. I probably said that wrong. My apologies to the Germans. I'm right in the vicinity of the DC side here, so I do hope there's discharge resistors. Otherwise, I'm going to hurt. Oh God, look how many screws are here. What is that about? That is probably... Why have they got 2 screws here? I'll work that out later on. And what was this designed to take? It's going out there. No, I'm not really sure. Was that suppression? chokes for the variable frequency drive output. So what this does is the main supply comes in and gets converted to DC, and then it gets converted back to AC by basically a 6 transistor, I would expect, almost an H-bridge driver, so that each output can be positive or negative, and then the processor controls that. It pauses. I'm thinking the processor's got a lot in its hands. Because if the processor is actually driving normally you get dedicated processors. This might be one of those that is designed for variable frequency drives. That might be one, which means that it can autonomously have a module for driving those. That would be very, very interesting and logical too. Here is the screws. Hopefully it's not smothered in heatsink compound. Sorry for any noise here. I would have liked to work for Otis, really. Bit of a fanboy of the old brands. I don't like the corporate mentality, but their engineering, and they do tend to attract the geeks. So it would have been interesting, but it doesn't really matter. Life went in different directions. And I like the old electromechanical lifts. I like riding on them as well. Who doesn't? Oh, quick shout out to Benno, or Bino, whatever his name is. Benno, don't change the settings randomly in controls like this. It's not a good thing. If you want to work in the lift industry, get a job in the lift industry, and then you'll not only get paid to be in the lift industry, but you'll get to play with lifts all the time and get paid for it. What could be better? Sometimes I wonder if some of the best engineers are too shy to apply for jobs that they'd love because they're scared that they won't be good enough. Why is this not coming out yet? Is there another screw that I'm not seeing here? Sometimes there are screws that I'm not seeing. Or is it stuck down with thermal compound? Not really sure. I don't want to use excessive force here. I don't want to damage this, even though, quite frankly, I don't need an elevator control PCB. I think it's coming up. I should actually be exercising more caution because these capacitors could be charged. Why is this not coming out? Is this where I have to pause? Because this ain't coming out. It has that sort of feel, oh, you know what, it might be the fact that the rectifier is kicking at a funny angle. And because it's kicking at a funny angle, it's kind of blocking it from coming off. Let's try that. No, the rectifier has popped back down again. Oh, there it goes. Right. Ooh. Very interesting. So first thing I'm going to do, that is a very odd and very strangely specific IGBT module. I mean, I suppose it's standard. It's the sort of thing you'd find in generic drives. Let's check these capacitors for spice. Let's set this to 700 volts, 1000 volts DC in fact, and just probe across that and see if there's any juice left in them. No, I am safe. It should be mentioned that unlike the streetlight death beam capacitors, elevator ones, I'll just put a finger across. That's the final test. I'd rather have the surprise when I'm expecting it. It's worth mentioning that elevators kill babies differently. They smash them between the doors. That's how they work. So they don't need the death beam capacitors for that. So what do we have here? Oh, this also answers a question I had earlier on about the diodes. Okay, so I was looking at these here. These look like two Smithfield power supplies. The chips are, oh, they're Viper 22A. How very stereotypical. It's a dedicated, I think that's a fixed frequency switch mode chip. The transformers they look proper transformers. They have the double insulated windings on them, which is good. Triple insulated, I think they even call that. It's basically the secondary winding, the bit that's supposed to be isolated. It's a bit for all the serial networks and stuff like that, and the switch contacts. So you don't want to fry your lift engineers. Elevator mechanics, if you're in America, they put extra insulation on the secondaries to isolate. Now, why do they have two? One will be the 5 volts for the processor, although I'd expect another regulator for that. And the other one may be supplying the 24 volts. I think of multiple voltages. And 15 volts. I'm seeing pairs of capacitors here and little inductors. I wonder if each one does 2 voltages. It does look like it. 2 diodes. 2 diodes. These must be putting out 2 voltages per switch mode. I've seen 15 volt. I would expect 5 or less for that. I've seen 24 volt. What's the other voltage going to be and why is it going to be that? What's the feedback? There's the opto-isolators for feedback. They've just copied and pasted this module across. What's the little 431 AC? It's a 431 voltage reference chip driving the opto-isolator for feedback back to the switch mode chip. Loads of filtering, capacitor and inductor capacitor, very common, but quite neatly implemented. That relay there, is that relay doing the resistors? The resistors in series for dissipation, and they do appear to be going over to that relay, although it's hard to tell because I think this is a multi-layer circuit board. Might not be. They are very prone to having multi-layer circuit boards. Yeah, it is multi-layer. I think they've got a screening layer at least in the middle. It makes it very hard to reverse engineer these. There's protection diodes on the output side for the opto-isolators, for the input side as well, and current limiting resistors. I would expect them all to have just tons of protection for something of this quality. There's the signals over to the IGBT. Are they? There must be opto-isolation built in. There must be opto-isolation built into that. That's good because it means if that module blows up, it's not going to feed back and blow up the processor. So what's this other relay for? Oh, that relay might. I'm not sure about this, but that relay might actually just activate the whole power section here. Would it do that? I would expect the switch mode power supplies to be powered from this. I'm not really sure. Is that either a inrush limiting circuit or is it a discharge circuit? I wouldn't think it'd be a discharge circuit. Could be wrong though. Because these will actually pack quite a whump. If you were to touch them while they were fully charged, it would be a very, very bad experience. It would ruin your day. EPCOS. I'm expecting these also to be premium quality capacitors. Goodness knows how old they are. Any signs that they've been changed at any point? No, the solder joints are very clean. They look like lead-based solder, so everything's going to be super. Yeah, that's interesting. That's more or less it. So what we've got here, oh, what's that chip? Atmel 24C64AN, that's a memory chip. That's going to store the settings. Right, tell you what, I'm just going to pause. Just going to go and look what this Infineon chip is. I think that may be special purpose. Just give me a moment. 1 moment, please. Okay, I took a look at the data sheet. It's very big. I didn't see anything specifically relating, though. Although it's a 16-bit, very capable processor with all manner of networks, including CAN bus, it didn't specifically state it had a module for variable frequency motor drives. And I'm looking at this MOSFET module here. I don't know what it is. I don't want to start ripping it off the board because that would be very destructive. And the number is apparently on the other side, which is a shame. The 5 connections at the side, we get positive and negative plus the 3 outputs. And then I'm wondering if this is a fairly intelligent module. I wonder if it's been given information or if it's just a dumb IGBT. There's a possibility it's actually being sent data on direction and sort of speed. I'm also thinking, where are the current sensing resistors? Is that also built into the IGBT module? It's possible that it could be a dedicated module just purely for that task. That would make sense given that, variable frequency drives are so general, like every factory has like loads of them. But a very nice design. Very robust looking design. It's followed all the rules, which is what you'd expect for something designed in Germany. Definitely something you'd expect in an Otis product. So there we have it. That is what the inside of these motor drives look like. It's worth mentioning that the motor drives have to be very powerful because it's not just closing the elevator doors for the car itself. As the elevator comes into level, the doors will lock onto the outer doors in the landing. So the landing doors are also powered open by the car, and also they have to overcome the fact that they are biased deliberately, often with weights, to actually close. If the car was for some reason to move away, perhaps be manually wound away during a rescue from those doors. If the car goes away, then the landing doors will close themselves. Also, the doors could be made of metal, they could be made of glass, and there's also always the friction aspect of the fact that they've got the guide rails with the gibs going down into them to actually keep them in position, and dirt and stuff goes into those. And mechanical tolerance and wear and tear, it's just, they have to be powerful. This is why it's got a three-phase motor and all the current sensing, so it can actually properly deal with just every scenario. But there we have it. Well worth looking inside. Quite an interesting device. Very textbook in a way, but nicely implemented.